My name is Clemens. This is my colleague, Roberto Cervantes. We're going to talk today about, once the slides show up, we're going to talk about event-driven applications with Azure Messaging. Roberto is going to do the bulk of it. Next slide. So we have to click it, advance it with, OK, well, we'll figure it out. So Roberto is going to talk about Event Grid and the things we're doing in Event Grid. We have some new things. There will be a demo, I think. And then I'm going to talk about metadata and eventing and a bunch of things we're kind of doing in the standard space, some updates, some things I'll talk about last year, and some new things that I want all of you to take a look at and also give feedback on or tell your friends about. But that later. For the first half of this talk, or a little bit more, Roberto is going to tell you about event-driven applications in Azure.
Thank you, Clemens. Yeah, it's working now. OK, thank you. This is my first time here. I'm happy to share more about what we are doing in the event-driven space. I'm going to talk particularly, I'm PM for Azure Event Grid. And I would like to share with you what we have been doing in the last few years. We have been investing a lot because we have been evolving. Event Grid has been evolving too much. We are not just a traditional event broker that we are doing push delivery. We have integrated new mechanisms with pull delivery. We integrated an MQTT broker and more. And this is what I want to talk with you today. There's a lot of opportunities. There's new spaces that we are reaching with Event Grid. And it's part of the evolution that we have seen in the event-driven space, not only in Azure, also in Fabric. So this is a good conversation that we have today. Let me share more about what we are going to cover. We are going to see more about the web and webhooks, the traditional space where event-driven has been working for many years. We also have the MQTT space. We are going to get deep on that. And we have messaging and streaming. Let's start with webhook and web. If you remember, Event Grid has many resources. If you think about Event Grid, there's no one Event Grid resource. We have many that they are focused on particular use cases. We have system topics, domains, custom topics, partner topics. All these has been for several years. And we have been maintaining, improving, securing. And this is part of the evolution that we also did a few years ago with the introduction of Event Grid namespaces. With the idea of having Event Grid namespaces as part of the standard tier is because we want to introduce flexible consumption models. What it means that we can now pull. But this is, don't get me wrong, this is not that we are replacing the push delivery mechanism that we have today with event-driven. We want to make it bigger for you. You have the benefit that if you have particular scenarios when you want to have a subscription with push delivery, but you have also requirements when you need to pull in certain circumstances, you can do that with the same resource. And also, we are introducing the MQTT broker for some IoT scenarios. So this is part of the things that I would like to share with you. We also hear feedback from customers regarding to, hey, I want to consume events from private destinations. How can we do that? We are enabling private link support with pull delivery. This is part of the thing that if you are interested to consume events with, in private destinations, you can do it with pull delivery. As well as we have been introducing a message retention policy and more. As I mentioned it before, we have MQTT broker as part of the Event Grid namespace. What is an MQTT broker? An MQTT broker is just another broker, highly scalable, low latency, and secure. The idea of having this broker in Event Grid is that allows devices to connect with applications and applications with devices. We are not only introducing the traditional models where we have APIs and we can go directly to our applications, but also to clients. And we are going to explore some scenarios that we have in this space. Let's start with the industry use cases. There are many use cases that we have been exploring with customers that are very, very excited about this broker. We have predictive maintenance, we have security, we have remote monitoring, connected environments, a lot of new areas where Event Grid is actively participating in new projects. And with these new industry scenarios that I'm talking, we have new patterns that we're introducing. We have scenarios or patterns like many-to-one, one-to-many. We have one-to-one. This is the kind of new scenarios where we are connecting devices with applications. Event Grid not only talks about HTTP requests, we have also MQTT as a protocol to communicate. So this is part of the new things that we previously announced, and we are improving, and this is what I would like to share with you more about what we are doing in this space. This is exactly what I would like to focus. Let me talk about Sparkplug B. Sparkplug B is a protocol, it's a specification that is used a lot in the industry for industrial IoT. The idea of Sparkplug B is that we can package messages and we can send it in just one single request. We can send a lot of information in just one single request. The idea of have all these kind of standardizations as a free form MQTT broker, we can leverage an event grid for all these kind of scenarios. For example, we can use event grid to communicate with other applications in IoT scenarios. We can send complex messages to an SCADA, for example, application. We can subscribe. I'm going to show you in a moment a demonstration about how we can do this with event grid, and we can also use other advanced scenarios with Fabric. That is a pretty cool integration. The idea of Sparkplug is that everything relies on the edge of network nodes. With these kind of nodes, we can group the devices that are producing the messages. And these devices are sending the messages like in batches. We can package all the messages and we can send it to the broker. And this is a way where in industrial scenarios, we can make more efficient the request. I don't need to create just one single topic or multiple topics and communicate all my devices to multiple topics. I can create a particular definition. If you see the format that I'm explaining there, we have the definition of the Sparkplug B, we have the group, we have the type of the message that we are going to do, and we have also the edge node ID. The edge node ID is the definition that we are doing in the client side. With this definition, we are grouping the devices. Once we group the devices, we can send that information to the broker, and we can successfully process to subscribe or to do whatever. Another thing that is important to mention here is the message type that we are defining. For the message type, we cannot publish data if we are not registering the kind of data that we want to announce. For example, I need to announce that this message will be a new message, it's going to be, or I'm going to delete or kill the message. There are some kind of definitions, particularly for this specification, that we will see during the demo. And this is how Event Grid is taking new scenarios in the industry, not only for the traditional messaging that we already know. Can you raise a hand who has been working actively with Event Grids? I would like to know. Event Grid namespaces? Okay. System topics? Okay, thank you. And in this space of MQTT, I also want to talk about the unified namespaces. And what is the unified namespaces? Think about a traditional automation line of production, of integration. This is part of the traditional process. If you see in the right side, we have the PLCs, we have SCADA, we have the management system or the manufacturing system, we have the ERP, and we have finally the intelligent cloud. The idea of this linear process is that we were pre-processing or sending information or taking information from each one of the lines one by one to finally put all the information together in the cloud. This is the traditional process that a few years back the industry has been doing. With the unified namespaces, what we wanted to do is we want to put everything in as a single source of truth. We want to connect all these subscribers or all these smart applications, let's call it like that, smart applications. We want to connect all these smart applications through a particular definition. And this is where Sparkplug B and unified namespaces comes together, and they can contribute and they can collaborate in that scenario. Imagine that with unified namespaces, you can define the structure and events for all your business, not only for the events that are produced by the devices that are the sensors. Imagine that you have sensors that are producing events in the PLCs, through the PLCs, but also you can correlate all the information that is connected through all the smart applications that you have in your organization. So the idea of these kind of models is that we can leverage on these practices for the industry, also using Event Grid. And this is part of the interesting approaches that we have now. Another area that I would like to share with you is that we are doing a lot of investments in the MQP space. We are committed to bring MQP soon to public preview, and we would like to announce this with MQP 1.0. We want to have an standardization with the industry. We want to make reliable security, and we want to bring particular features for Event Grid. For example, we have claim-based security, we have renew lock, WebSocket support for WebSocket, Enter ID. This is kind of the feature that we will be announcing for MQP. Another thing that I just want to share is we are working very hard to bring all these integrations with the same philosophy that we have in Event Grid. Make it easier. We want to continue making seamless integration with other Azure services, and we want to create a good developer story. That's part of this experience. And aside of the MQP, we also have a good story with Fabric. We recently announced, if you are following the Fabric news, we recently announced a new connector in Real-Time Hub. So if you are publishing to the namespace, you can connect from Fabric, and you can take your messages from the namespace topic into the Fabric world. This is a very interesting scenario. Why? Because now you can start building a pretty interesting solutions. Imagine in this scenario, this is an automotive fleet solution that you have devices that are producing information, and these devices are landing in Event Grid. Once they are landing in Event Grid, you have a function that is pre-processing and doing all the things that we can do in a function. Maybe we are processing a particular condition or something. And finally, we are landing all the data directly into an event stream. Yesterday in our session, in the previous session for Real-Time Hub, we mentioned that event stream is the front door for all the messages in Fabric. So the idea is that if we want to start introducing all this data into the Fabric world, we can connect directly with event stream. And from event stream, we can send it to an event house. We can do any report that we want, or we can create activator triggers just to react to the information that we have. This is part of the powerful solutions that we can build today. One thing that I would like to share today is about what's new in Event Grid. What's new? Well, we have been doing a lot of investments in security and also to improve the cross-tenant scenarios that we have. We have been listening customers that wants to deliver to a different tenants. And this is part of the improvement. We have improvements in order to deliver to a webhooks or to deliver to services that are in other tenants, like event hubs, namespaces, service bus, storage queues. These kind of integrations are very, very popular. We have been listening from customers, and also we improve the security with the next network security perimeter integration. This is for topics and domains. The idea is that you can create a logical boundary, a logical security boundary, where you can connect Event Grid with the subscribers and publishers. This is a pretty interesting feature that is in Azure. You can check it today if you are interested to secure your public resources. This is an interesting scenario. We also hear feedback about managed identity support for webhooks. So this is another pretty cool scenario where if you don't want to use the Entra scenario, you can use managed identity directly. And for MQTT, we have a pretty cool scenario. We have the support job issued by Open Connect providers. This is another one that we have been listening a lot about. Hey, we want to send our own job token based on OpenID Connect providers. So this is another good one. And we have support dynamic authentication using webhooks and Azure functions. This is a pretty useful scenario when we need to send the credentials and all the security authentication information to another destination, for example, the webhook. Imagine that I have an intermediary layer where I want to authenticate or do a particular process. I can delegate that information, that security information, and I can continue the flow, securing all the path. Give me 1 second. Okay. And the last one that we have is assigned client identifiers. What it means, that when you are working in MQTT space, you need to define identifiers for your clients. You have 1,000 of clients you need to define. But what happens if I don't want to do that? I can go directly and just use it. And we are going to assign an automatic identifier for you. This is a new feature that we're introducing. Is currently in public preview. If you are interested to explore MQTT, this is a good scenario. And what is coming? Many of the things that I mentioned that are in public preview, we are going to GA. We are committed to bring all these things to GA. But also, we are going to introduce new powerful scenarios like MQP support. As I mentioned it before, this is something that is coming. The other one is retain an HTTP publish. This is important in the sense that now if you want to publish MQTT messages, there are customers that they want to do it with HTTP. Under certain scenarios, I want to have this flexibility. I want to do it directly with my client using MQTT, or if I want to use HTTP. And this is a good improvement that we're doing there. Another one is, imagine that I have thousands and thousands of devices. I don't want to register one by one. What I want to do, I just want to create a bulk insert and put all the devices in one place. So we are introducing a new bulk API just to register all the devices at once. And the other one that is a pretty good one is we are increasing the messages for MQTT to 256 megabytes per message. This is another big one that we are going to have soon in private preview. Another one, and the last one that we have here is the shared subscription. In case of, if you want to publish messages to an MQTT topic, you can share the topic across multiple devices. I don't need to create one topic per device. I can create one shared topic, and I can manage the subscriptions because now we have a gateway that is routing the messages across the clients. So this is part of the improvement that we continue doing in the MQTT space. I would like to use this time just to share this survey. I will appreciate if you can scan it. There's a small survey about what you would like to see in Event Grid. I want to use this time to hear from you. What are you using? What would you like to see in the product? If you can help me with that and share any feedback about what I'm talking right now, or if you are interested to get connected directly with me or my team, that would be great.
We'll leave this up on the screen for another few seconds. Well, Roberto's getting ready for the demo now, right?
Yeah, well, yeah.
Let me talk about the MQP support real quick and one extra round. What we're going to do is we're literally going to go and align the AMQP level support across Service Bus and Event Hubs and Event Grid to be the same for most of the base level interactions. So sending, receiving will work the same across all of these systems. The goal is that we will able to go and eventually create APIs that are also kind of portable across those services. What doesn't change is that we will still have 3 brokers. Service Bus will continue to be the transactional heavy-duty queue broker. event stream will still be the super high scale, super predictable stream broker with Kafka support. If you want to have Kafka, you're going to use Event Hubs. If you want to have things like JMS and transactions, etc., you're going to use Service Bus. But there are very, very many scenarios today which are already kind of covered by Event Grid, where Event Grid is kind of good enough for 80% of all cases. And so to make sure that you don't need to necessarily make a call and that you can grow up into Service Bus, you can grow up into Event Hubs. This is the first step, adding that AMQP support and then having SDK so that you can go and build basic applications that basically work against Event Hubs or Event Grid or Service Bus or Event Grid, and you can go and make a choice of in which directions you want to have your applications grow. And because of hygiene, we want to make sure that we have consistent protocol coverage across all the services that we have, which also makes kind of integration scenarios obviously much easier. So, demo.
Perfect. Let's do the demo. What we have here is just a small sample of industrial IoT devices. This is a simulation that I'm going to do. And we have Event Grid in the middle. Event Grid has enabled the MQTT broker, and I'm going to configure this in order to send and receive messages. I'm going to use Sparkplug as the protocol, as the specification. And you will see some of the differences, at least from the client side. And I'm going to subscribe to receive the messages, MQTT messages in a webhook. And we are going to send all this information to Fabric. We are going to use Fabric to send this to event stream and then store that information in Event House. In order to do this, I created this small application. This is a very small application where I have, OK, let's do this. Here. I'm going to open this application. This application is just is a simulation for an application. Like I mentioned it before, when we are doing a Sparkplug B, we have applications that are consumers, and they are subscribed to the broker, and they are going to react depending on the kind of messages that we are going to produce. What I'm going to do, I'm going to subscribe to Event Grid. I'm now connected. This is the application that will be receiving the information. Imagine that this is a SCADA. I'm just subscribing to get information that is produced by the devices. And now I'm going to open another application that is my node. In this application, I'm going to connect. And what is going to happen here is that my node is already connected, and I already have registered a device. If I go back to the subscriber, what you are going to see is that I can start sending information. For example, if I click connect, I already connected, actually. I can click BERT. Let me see. I'm going to disconnect. It's working. OK, now it's working. It's there. If you see the messages that my subscriber is receiving, I have the end BERT and end dead messages. What it means, I'm announcing the node has started or is initialized, or I killed the node. And this is the way I can start sending messages to the broker. It's part of the functionality that we have. I can start publishing in case I want to subscribe. For example, node is disconnected. It's disconnecting. But let me see if I can send again. No. Let me kill the application again, and let me try again. Let me connect again. Pop. And I'm going to connect. Pop. And let me see if I can send. Pop. OK, perfect. Now it's connected. And what I'm going to do is that now that the application is connected, I don't know why it's disconnected. It's disconnecting. But the idea behind the scenes is that I'm sending all this data directly to my viewer. In this case, this is a webhook that is receiving the information. All the MQTT messages, what I was doing with the demo is that I'm doing a bidirectional communication. I have two applications. One application is the node that is producing the messages. The other application is the application that is subscribed to the messages in MQTT. I'm using the MQTT protocol. I'm doing this bidirectional communication. But at the same time, I'm routing all the messages to a webhook that I have here. And this is the information that you are looking. This is the messages that I have been doing. You can see all the messages that we have. And this is an interesting scenario because we are also are working in the protobuf integration. So this is part of the things that we would like to share. this is part of the information that we are working. And finally, one thing, and the last one that we are doing is we have event stream as an endpoint. We are receiving all the information. We have the new source that is event grid. We are sending all the information to the event stream, and now we can store the data directly into Event House. In this case, I can come directly to Event House, and I can see all the messages that are coming from the MQTT devices. I'm catching all the information.
Yeah, so what's important, one of the things that didn't quite come through was we didn't invent Sparkplug B, right? So Sparkplug B is a project that exists in Eclipse.
Yeah.
And it's been driven by folks in the industrial space. And it has a very particular way of how to handle MQTT. And one of the greater criticisms, I would say, out of the MQTT community about IoT Hub was, hey, we have this thing, we have this convention that we worked with, and Sparkplug B, and you have this fixed topic structure in IoT Hub, we can't use it. And so what we are doing with Event Grid, and with the new features that we're just rolling out now, like retain and last will testament, is that we now have the feature set to support something like Sparkplug B, as Roberto just showed. So you can now build a Sparkplug B application as kind of this little demonstrator, and you can hook it up to Fabric, as we show, because we have this direct integration between this MQTT broker and the streaming engine. So the nice thing about Event Grid is that it's a hybrid. It has both a full-blown MQTT broker to it, but also this routing engine, which then allows you to kind of grab into these MQTT topic spaces and extract metadata, extract streaming data that comes out of those MQTT channels and then route them into Fabric. So we can go and do this with any arbitrary topic tree that you set up in MQTT, but also with standards-based or convention-based things like Sparkplug B. And that's kind of what Roberto has been showing here.
And back to you.
Okay, so slide deck?
Yeah, let's do that.
Fantastic.
Yeah.
Let's see whether that works. It does. Thank you. Thank you, Roberto.
Thank you.
So in the next 20 minutes or so, I think is this counting down? No, it's not. I'm going to talk about metadata and messaging. I'm going to connect up to what Roberto just showed. And where's my Roberto? Help me, okay? Where's my browser? How do I get there? Okay, great. Oh, and I don't have a touch screen, do I? Roberto has given me an inferior computer to work with, which I find deeply problematic. Anyway, so there's a, can I go and do this? No, I can't do that either. Roberto? I have a, no, I have to go and, I think I have to do everything manually on this inferior machine, but it's.
Go ahead.
This is what comes from not using God's own operating system. Unified namespace. He's been talking about this. So the unified namespace is a concept that has been popularized by some bloggers in the US for the industrial industry. It's actually pretty clever. You go and take all of the machines that you have in your factory are gonna get assigned a particular path where they go and post their status messages. So you have a production line, and in the production line, you have an organization where you say, I start with the factory, and then the factory has a line, and in the line there's a cell. In that cell is a machine. In that machine is a sensor, and that sensor has an ID, and that's the topic where it publishes its stuff. And if you go and take all the MQTT brokers and they turn around and publish their MQTT messages into a downstream MQTT broker, then you get a unified view of all the MQTT stuff that you have in your factory. That's the general idea. That has efficiency problems, but it's a popular thing, and so we're like, we're going to go and support the SPs. So I made an experiment. I had a conversation with my friend Copilot and said, hey, here's the Volkswagen manufacturing standards, how Volkswagen builds factories, and here's the unified namespace concepts. And I did this during a drive, and so we worked out a fairly long document, and I kind of distilled it down. And then we said, so let's go and talk about the Contoso AutoWorks factory layout. So there's and so how is a car made? Where there's a stamping cell, there's a laser cell, there's a welding cell, painting cell, oven curing cell after painting, axle assembly, bolt tightening cell, windshield integration installation cell, wheel assembly cell, CAN bus test cell, roller test cell, water leak test cell. That's enough, right? So in every single cell, there's various different kinds of things. There's the stamping cell that's creating basic parts, external parts for the car, has a coil of this roll of steel that then gets stamped by a press. So there's all of these different things. And you see that there's a topic path associated with each of those things. And so we go through this, and I'm not gonna, I could talk about this obviously for hours. Then there's some traceability, like how we have these work pieces that need to go from A to B. The manufacturing execution system basically schedules that work. So all of that needs to be captured here too, and it kind of then generally is. And then you see this popping up, this xRegistry piece here, because there's a missing bit here when we talk about these things. And that's also true in the unified namespace world. People talk about topics and people talk about payloads, but people don't talk about how do you capture this in a formal way. So in xRegistry, we have inadvertently, without wanting to, invented a formal way of defining what a unified namespace looks like, because if I scroll back further down in this document, you will start seeing a JSON document, and I have to go and zoom on the inferior machine a little bit further in. So there's a bunch of message groups here. So there's the Contoso body stamping cell, and you see that there's a message called coil feed status, and you see that there is a particular protocol that has been invoked here. That's kind of setting the MQTT protocol. And you see that there's a topic name, and there's a quas setting, and there's a retain setting. So these are protocol level options. And it links this message to a data schema. Those data schemas are at the bottom of the document. So every single message that you see here is associated with a topic name. And when you look at the topic name, that's actually a URI template. You can now, so this is the only known to me way of just formalizing what this unified namespace setting actually looks like. Because we can go and define the MQTT messages here, and those MQTT messages will then go and link to their payloads, and it's obviously a little long. The payload definitions kind of start here. That's where the schema groups are. And so that's the second set of definitions. And you have schema groups, and you have schemas, and each schema has has some content here. And so that's your schema definitions that then go with that unified namespace definition. I show you this just mostly to connect up to what Roberto was saying. It's helpful to have metadata, to have formal descriptions of how those things are. And so we found a way to go and do this. Let's go and depart from this scenario and just talk about this in a bit more general terms. Oh my God, I just hope that it works. On Windows, this would be Control F5. What? How do I get back into current? Do I need to hit the button? Okay. I mean, it's Windows inside of a Mac, so you're making this even harder for me. So metadata. Metadata and schemas. Many of us are kind of working in the JSON world and sometimes in the XML world, and schemas are kind of optional. They're a little bit less optional on the XML side there, but they're very optional on the JSON side, right? Everybody's just punting JSON stuff around. That is coming into question of whether that's good, because it is not good for data quality. So the problem, the reason why we need more schema is we need to have better idea what that data structure means. If I give you a JSON document or a JSON structure, there is some metadata contained. There's a label name, and then there's some inherent type information. It can tell you whether it's a bool or a number or a string or null. It can't really tell you precisely what that string means. It can't really tell you precisely what that number means, because also the JSON has an incredibly broken number model, because the underlying number data model is an IEEE double. It's not an integer. So there are some integer numbers which you can't legally represent in JSON, or which you can't rely on that they're properly transported. Now, the funny thing is the JSON representation in text is base 10, but the JSON representation in memory is base 2. So that caused all kinds of breakage. It is a terrible, terrible encoding. We're still using it, but so schema helps, because schema kind of clarifies the intent. You're gonna see that more and more of JSON is going to be annotated with schema because of that. But even more so, I'm dissatisfied with the machinery. But even more so, is this going to come back? Yes. So, but even more so, metadata for AI is going to be a huge topic. And I'm not of the hype bunch, so my personal experience from working with AI and with generative AI is the better constraints you give, the more you kind of constrain the LLM in what you allow it to do, the better the results are, the more predictable they get. They are trained on human language. They're trained on full text. And they really appreciate a description of a thing. So if you go and write a schema about a data structure and you give good description text, your LLM will do better work with it. The description text, however, doesn't appear in the JSON instance document. It actually only appears in the schema document. So it's going to be good to have schema for it. Then there's further information you can give in a schema document, like telling the model what a temperature is. Because we have Americans in the room, temperatures has choices in terms of units. Inexplicable to Europeans, but it is so. However, there's still Kelvin, right? There's scientific units. There's also things like volume, length, all of which should be expressed in meters, but they're not. So that's stuff that you probably want to go and make known to a model, which is pretty dumb, but pretty good at transformation. But you want to give kind of as much data as you can. So schemas will matter. There's 3 things I want to talk about. CloudEvents, xRegistry, and JSON Structure. CloudEvents, you should be familiar with. If you're not, read up on it, cloudevents.io. It's a standard, it's a convention for defining simply what an event is and how an event is bound to protocol. It doesn't invent new protocol. It basically says there are 7 attributes that make up an event. There's an ID, there's a type, there's a spec version that's referring to the version of CloudEvents, which will not change in my lifetime if I have a say about it. Source, the time, the subject, what is that about? And then the data schema, data content type, describe what's contained in that event. We have had 40 companies which have worked on this until about 2019. Since then, the CloudEvents working group exists to mostly defend the fort and to fend off any attacks against the 1.0 version. We're doing amendments, we're doing extensions, we will not change the core. A cloud event looks like this in the JSON encoding. You have a bunch of standardized headers. If you're building business applications, those headers will be okay for you in most cases. And then there's a body, and you see this kind of expressed here in JSON. You can also go and make any AMQP message, any Kafka message, any message you send today, you can simply turn that into a cloud event by simply annotating it with extra headers. It's built so that it integrates with existing protocols. So it is a way to just normalize your events. Read up on it, cloudevents.io. Once we had built cloud events, we're like, okay, so the way how we saw then people advertising their cloud events that they're raising is on documentation pages. And of course, what we want to do is we want to go and formalize and basically build a formalized way for you to be able to declare, I raised these 5 cloud events, so that it becomes machine readable. So we need to have a mechanism to do this. And the mechanism to do that was first, the idea was cloud events discovery, and then xRegistry. xRegistry is an extensible registry for metadata that is particularly geared towards endpoints and schemas and message metadata. And what it does is it basically gives you a formal way of formatting a stream. A way to, I say that in other ways, is in a database, you have a schema that defines tables and that defines the structure of the data you already have. xRegistry defines a schema of messages and event schemas, and that defines a schema for data that you don't have yet, that's coming through a pipeline. So you can go and demultiplex that pipeline, and you can go and then operate with this, and you can go and do, you can generate clients, you can go and generate event stores, you can go and analyze visualizations. As soon as you have metadata about your events, you can do more interesting things. Roberto, hang on. So I found this. So I can get to the Windows button. Yeah. Now I need to go and type because no, that's not what I want to do. So I'm going to go to xRegistry. /spec. Now, I'm really bad with other people's computers, especially. See, I have 2 Macs, but they're living in my drawer because I have no real good use for them. So here's one of my favorite documents in that way. I'm going to go and make this larger again. Okay. I think I can make this disappear, yes. All right, so here is an event if it is still too large, it's still too small. Now you can see. So here's an event definition. There is a message groups definition, and that is a message group. Think of a message group as an interface, right? So a message group has a set of events in it, and if you pull on the message group and you associate that message group with an event stream, you now have a set of events that are supported by the event stream, incoming and outcoming. You know what to expect and you know what's allowed. So in that are a few events. Fabricam.lumen.turned-on. There's an event, fabricam.lumen.turned-off. So this is for a light bulb. There's fabricam.lumen.brightness changed. And there's fabricam.lumen.color changed. So those events are what a light bulb will raise. In all those events, you see that there is a set of definitions for the envelope for that event and the envelope metadata. So there's an ID, there's a type, there's a source, time is required, and there's a data content type. So that is now a formal way to describe your events. And that now links to a data schema URI. That links to a data schema URI, and the data schema URI, it then points to the schemas for your payloads. So the nice thing about xRegistry is that it allows you to go and define these things in a file or in an API server. So the an API server for this is, we have xRegistry, xregistry.soaphub.org. Question mark UI. Okay, so this isn't, oh God, holy shit. I'm sorry. Sorry I said it. To everybody online, I didn't say that. Wait, where did it go? I closed the whole thing? I don't know how I did that. I'm sure that was some weird trick. Okay. So we're gonna, I clicked the button in the corner. That's just me being just bad in terms of control. So this is the server version of this. This is the official xRegistry server, and you basically see the same kind of message groups here, and you can go and navigate them. So this is kind of the API view, a little UX that's kind of laid over this. So you have your message groups. Those message groups have then messages, and then every message then has kind of its envelope metadata. That's how you can go and navigate this. This general format now allows you to go and generate documentation, generate clients, and do all those things with it. You remember Alicia had a fantastic presentation about the new schema capabilities and the schema-driven capabilities in Fabric. They're all driven by the metadata that sits behind this. So xRegistry API is what you use for that. Now, we've also been asked, like, okay, so what's the story about metadata in agent land, right? MCP servers, agents, all these things. And so we have a flexible registry, right? We have a flexible registry which allows us to manage schemas and manage endpoints and manage messages. So we thought, well, let's go and see what else we can do. And so there's a site that is temporary, mcpxreg.com. And mcpxreg.com, always doing the zoomy thing, has a few more xRegistry plugins and a few more models. For instance, an agent card provider. So these are A2A agent cards that you can go and navigate with this thing. Then there's API providers, and you have APIs, which have multiple versions as schemas do. And here's your open API document. And then there are container registries. And so there's a OCI compatible container registry, which is the Microsoft official container registry, which is being proxied through this interface. And then there is .NET registry. And .NET registry, this is literally NuGet.org with all the packages that exist here, which are projected through an xRegistry interface. Why does that matter? Because LLMs like constraints, and they like to have a single API if you can make it so. So what we're basically doing here with this is we're pulling the entirety, like behind this little website, there are literally 2.5 million assets. Because I'm pulling in PyPy, I'm pulling in npm.org, I'm pulling in effectively all the major package registries, and I can cross-reference them. So if I have an MCP server, or I have a thing that kind of raises events, I can go and cross-reference to packages through one consistent metadata graph. So that's a thing that's kind of looking to the future. It's current development, but one of the goals that we have with the xRegistry is to go beyond what we do with messaging and to really kind of build this uniform metadata graph that kind of gives us a way to go and navigate all these things in a consistent fashion for the benefit of LLMs. And I know where we are in time, so I'm going to get to the next thing. This is something I would like to get some help, support, cheering for, because I'm trying to solve a real problem for everybody. We are about to submit this into the IATF as an internet draft. We're figuring out what the right venue is. JSONstructure.org. JSON Structure is the parts of JSON schema that you like without any of the terrible parts that you all hate. There is no one-off, no any-off, no all-off. There's no not, there's no if-then-else, unless you really want it. There is a proper type system. So this looks completely like normal JSON schema. Like you look at this, you glance at it like, this looks normal. What's different about it is the type is now required, because that's optional in JSON schema. The name is now, there's now a name required, and there's constraints on the property names. So the property names are now so constrained that you can't always use them for code generation. You can always use them for mapping into databases. There are expanded data types. You can now go and say type int64. You can now say int time, date time, or duration, or UUID, or JSON pointer. And decimal maps to a string and not to a number because the number system in JSON is broken. So it still looks like JSON schema, but it has a real type system to it. And it is not a pattern matching language, it's a data definition language. It has annotations for scientific units and currencies. Scientific units also with composites. So you can say meters divided by a second square. That's a formal thing you can do. I'm not inventing anything. I'm just taking that from other standards and just mapping that into the spec. And so you can go and annotate very, very well your structures. And I already did some demos on the way, but let's, I'm going to show you the website carefully. Okay. So JSON, here we go. JSON-structure.org. So that's the website. And so there's a bit more of an expanded example. I still need to make this bigger. That works. So you also see alternate names. I can go and give things display names. So not only their label, I can also give particular names to, like this is how, when this gets JSON serialized, you're going to use this name for the tag. And you can go and use these alt names for whatever purposes you want. So there is a formal spec. There are actually 6 formal specs. The first spec is the core. That's linked from here. And that already looks like an RFC. I hope it's very legible. It's simpler, actually, than JSON schema. It's also much easier to read, but it has a bit more text because it defines more types. So you're invited to go and take a look at this. If you like it, talk about it. So what we're trying to do, honestly, is we're trying to fix the problem of JSON schema. JSON schema is a problem because it's too complicated. And what we're trying to do with JSON Structure Core is we're trying to reduce the scope of it and make it simpler, but yet give it a better type system. If you care about any of and all these things, you can go and get them because there's extension specs that add them back. But at the core, if you simply need a data definition language, if you simply want to go and define your messages, or if you simply want to go and define your request response responses, then JSON Structure is going to be the better choice. So JSON-structure.org, go there, look at it, see what you like it. There's a forum in GitHub where you can go and post feedback, share it on LinkedIn. Because if you like it and if you make noise about it, it's going to happen. But this is what standards is. Standards is also kind of a bit of, people need to go and see it and people need to say something about it. Because we really, really need to fix it, because we need to have open APIs that actually compile and yield code. And it's much too easy with JSON schema to basically just trip over your own feet and have non-standard extensions to do these things. I believe that you will like the extensions. There's also some really neat kind of new compound types in there that I don't have time to explain. So, and that was it for this talk. Roberto, with the intro event grid, let me just go and do the quick recap.
How we are evolving, what is the new features that we are announcing. We are mostly investing in MQTT space right now, and we also invest in Fabric. This is part of the things that we have.
Yeah, and then the MQP story is going to evolve over the next half year, where you're going to see also new clients that speak specifically to that interface. And then, where the metadata story is something that is currently happening kind of in the community, in the standard space, xregistry.io, JSONstructure.org. And you're going to see this showing up in products one after another. There's already kind of the product specs for how to make the brokers better using metadata have already been written. It just takes a little time to kind of find the time, and it's actually a lot of work to get those things done. You're going to see those things showing up, but JSONstructure.org is something I want you to go to, and xregistry.io. Go there, also familiarize yourself with the concepts, because that is also going to show up in the products and hopefully also in the greater community. With that, thank you very much for your attention.